This is the first session on matrices. First, we will see what is a matrix. Prior to that, if you just have an idea regarding the numbers, numbers are used to give information on a quantity. If you just need to quantify something, then you can use the numbers for that purpose. Then we can use matrices. We can use matrices to give information regarding two or more quantities in such an occasions given below. Here it says that as the example, there are three students named as A, B, and C, and they have got prizes for the performances in the examination. If you look about this example, this says that it is just a information or just a thing regarding the gifts that the A, B, and C got. It means the prizes that A, B, and C got for their performances in the examination. If we look about the prize got for the student A, that student has got 6 exercise books. Here it says that exercise books, there are 6 of them, and there are 3 pens as well. 6 books and 3 pens. This is for the prize got for the student A. And thereafter, for the student B, got a prize as well. In that prize, it includes 4 exercise books. In that parcel, you can see that there are 4 exercise books and there are 2 pens. This is for the parcel obtained for the student B. Then for the prize for C, it just contains 3 exercise books only. Just contains 3 exercise books. Therefore, in other words, we can say that there are no pens or there are 0 pens. Therefore, this is the prize got for the student C. And since this is the information regarding or the details about the prices that A, B, C, and C got, now we can tabulate this. It is just include this data in the table form. If you insert this data in the table form, you can write it in this way. Now suppose that if you are creating a table in this form, here in the first column, you are writing the student name. The student name is A, B, and C, student name. And then in the next column, you are writing how many exercise books in the parcel, number of exercise books, and in the next parcel, in the next column, you may write that number of pens in the parcel for each student. Now, you have already identified that there were 6 exercise books and 3 pens in the S parcel, and for the parcel prize got for the student B, there were 4 books and 2 pens. For C, there were 3 books and 0 pens. This is what we are generally doing. If you are having info data, then you are trying to show it using a table form. Then what we are doing in the matrices is we are converting this table into a form of rectangular array of numbers. Therefore, this table can be written as it is as the 6, 3, 4, 2, 3, 0. Those are the numbers appears in the table, and we can write it inside the parentheses in this way. Parentheses, or else you can use the box brackets. I will use box brackets here. Then this is said to be the form of a matrix. This is the form of matrix. Therefore, if you can see an array of numbers inside parentheses or box brackets, then such arrangement is said to be a matrix. Now, I hope that you have got a brief idea regarding what is a matrix, and therefore we will move for the definition of a matrix now. Definition of a matrix. A matrix is a rectangular array of numbers. Matrix is a rectangular array of numbers. If the array has m number of rows and n number of columns. In this example that we have discussed here, we can see that there are 3 rows. Rows were named for A, B, and C. It is for A, B, and C. This is for books, and this is for pens. Now you can see that there are 3 rows and there are just 2 columns only. Therefore, if you are having a definition for matrix, it is a rectangular array of numbers, and if this rectangular array of numbers having m number of rows while having n number of columns, then we are saying such a matrix as a m by n matrix. This is not the meaning as this m multiplied n. This is we cannot say that this is equal to mn. This is totally wrong concept. This is not the idea behind this m multiplied n. It is just saying that m multiplied n. This is just a notation only. This is just a notation only. And this notation suggests us the dimensions of the matrix. In this case, we can see that here we have used 3 rows and 2 columns. Since we have identified 3 rows and 2 columns, what we can do is, if you write this matrix again, you may get the matrix as 6, 3, 4, 2, 3, and 0. This is the matrix that we have obtained. Therefore, we can write down, normally we are denoting the dimension of the matrix in the bottom right hand corner of the bracket or the parentheses. Therefore, here we can say that this is the dimension is equal to 3 into 2. This is said to be a 3 by 2 matrix. This is said to be a 3 by 2 matrix. Here we are not going to multiply these 2 numbers and put it as 6. It is just a notation only. And now we will focus on the notations for the matrix. Matrices are commonly written in box brackets or parentheses. Matrices are usually symbolized using uppercase letters, while lowercase letters representing the entries or the elements of the matrix. It is quite like this. At the very beginning, I told you that to write a matrix, we are using parentheses or the box brackets. We can use either parentheses or box brackets to write the elements of a matrix. And once you are writing a matrix, then you must name that matrix. The naming matrix is you have to give a name for the matrix. It is just as if you just need to get an identification about something, you give a name. It is quite like this. This is quite like that. Therefore, we have to give a name for the matrix. Generally, we are using the English uppercase letters such as A, B, C, D, this P, Q, such as X, Y, Z. Likewise, we can use the English uppercase letters to denote a matrix. Generally, we are not going to use the letter I to denote a matrix. It is because this is a special case of matrix we are saying as inverse matrix. Therefore, apart from the letter I, you can use whatever any other letter appears, uppercase letter appears in the English alphabet to name a matrix. Now, as an example, suppose that you are naming the matrix as A, then we can say that A is a matrix we are having, and I am saying that this is a 2 by 3 matrix. 2 by 3 means according to the definition of a matrix, we have learned that here if it is a m by n matrix, then m suggests the number of rows having for the matrix and n suggests the number of columns in the matrix. Therefore, if this is a 2 by 3 matrix, it suggests that there are 2 rows and 3 columns. And inside this parentheses, you have to write down the elements, or what we are saying as the entries of the matrix. Then to denote if the numbers are there, then there is no problem arises of writing the matrix. But if the values are just representing using the alphabetical letters, then definitely you have to use the lowercase alphabetical letters to denote the entries or the elements of the matrix. It is quite like this. Now think about, since there are 2 rows, I will assign P and Q here, R, S, T, U. Therefore, likewise, we can write down the elements of this matrix. To name the matrix, we have to use the uppercase letters. To denote the elements or the entries of a matrix, we have to use the lowercase letters. And in the bottom right hand corner, we are writing the dimensions of the matrix. To write down the dimension of matrix, we are using the notation m times n, where m denotes the number of rows and n denotes the number of columns. Okay. Now we may focus on continuing the notations of a matrix. Here you can see that there are 2 matrices I have written here. In the first matrix, it is written inside the box brackets. You can see that capital A is the name given for the matrix, and inside the box brackets, we are having the elements. Rather than naming them as simple A, B, C, D, a special method for these notations have used. It is quite like naming the element according to the row number and column number. If you see about a matrix at the very beginning, you have had an idea regarding what is a matrix. We have learned it as matrix is a rectangular array of numbers. If it is a rectangular array of numbers, then what we had identified was here, we had here 6, 3, 2, 3, 3, 0. And here you can see that this is the first row, this is the second row, and this is the third row. First, second, and third rows are mentioned here. First row, second row, and third row appears here. Then we can see that the first column and second column appears here. When we are dealing with the matrices, we are generally using the row numbers and column numbers to denote the if the numbers are not given, to denote the entries or the elements of a matrix, we can use the notation combining the row numbers and column numbers. It is quite like this. Now think about, if this is the matrix A, then we can say that this is the element in the first row, first column. That is why we are writing it as A11. And if you are moving on the first row, then the next item would be, or the next element would be, it is still in the first row and it is now in the second column. Then A13, first row, third column. Then we can have, since there are n number of columns, it is the first row and nth column. Since this is finished, we can now move to the second row. To denote the elements in the second row, we can use it in this way. It is A21. It is the element in the second row, first column. Here it is A22. It is the element in second row, second column. Likewise, we can say it is A23 and A2n. If there are m number of rows, then the last row would be the mth row. Then it would be row m, column 1. Then element for row m, column 2. Likewise, we can move for the element for row m, column n. Then we have already identified that there are m number of rows and n number of columns. We write it here mn. Therefore, now we can write down the dimensions of the matrix as it is the m number of rows and n number of columns. It suggests that the dimensions of the matrix is m by n. And another term for the dimension, we are saying this as the order of the matrix. This m by n is suggests to be the dimension of the matrix. Or else we can say it is the order of the matrix. It is said to be the order of the matrix. We can use this m by n as dimension of the matrix or the order of the matrix. In here, it is showing that the parentheses have used to write down the matrix, and there is nothing new stated here. Instead of box brackets, the parentheses have used to denote the matrix. Therefore, same as previous, uppercase letter A has used to denote the matrix, and inside the parentheses, the elements have included, and appropriate row and column numbering has used to write down the entries of the element. And in the bottom right corner of the matrix, the dimension or the order of the matrix is included. Since we are using this notation form, we can summarize this notation into this A equals in this form. We can summarize this value as this. It is quite like, if A is the matrix we are having, we can write down the elements are in the form of A, I, J, where we are having a m by n matrix, and here we can say I is the row number. The possible values for I would be now 1, 2, 3 up to m. It is because m is the number of rows in the matrix, and same like this, J can be named as 1, 2, 3 up to n. Therefore, this is how we are writing the matrix in general form. Since this is denoting the A simple Aij or the lowercase letter a with this subscripts ij, we can say this as this denotes here. It is Aij. Here we can write this as I stands for the what we are saying as the row number. I is the row number, where J is the column number. Now we will move for the discussion on types of matrices. At the very beginning, it was stated that matrix is a rectangular array of numbers. And based on the behavior of the numbers inside these matrices, as well as the existence of the number of rows and columns, we may able to identify different types of matrices. The first form of the matrices is null matrix. The first form of the matrix is what we say here is null matrix. If all the, suppose that you are getting a matrix which is having all the elements as zeros, then such a matrix is said to be a null matrix. It is because since if all the values, now think about if you are having the matrix A in the form of a 0, 0, 0, so zeros. Now we can see that all the values or all the elements inside this matrix are zeros. It is 2 by 4 matrix. Therefore, we can say that A is a null matrix. It is because we can see that all the elements or all the entries of the matrix, since all the elements of the matrix are zeros, then we can say such a matrix is a null matrix, or another name is we can say null matrix, or we can say it as zero matrix, since all the terms or all the elements are equal to 0. The next type of matrices is said to be the row matrix. If you are having a matrix, matrix is said to be a rectangular array of numbers. Then what we can have is here, if you are having just only one row, if you are having only one row for the matrix you are considering, then such a matrix is meant to be a row matrix. Then we can have this example. Now think about if A is the matrix we are having in this form 6, 3, and 4. Here we can see that all the elements, here we can see that there is only one row. Therefore, we can say this as 1 by 3 matrix. Order of the matrix is 1 by 3. And we can say that A is a row matrix. A is a row matrix. It is because we can see only one row in this matrix. Similar to this, we can define the column matrix. If a matrix has only one column, then such a matrix is said to be a column matrix. If a matrix has only one column, then such a matrix is said to be a column matrix. Now think about this example. If our matrix is having 3, 6, 3, and 4 in this form, here we can see that there are altogether 3 rows and only one column. If you let this A equals 6, 3, 4 with the order 3 by 1, then we can say that A is a column matrix. A is a column matrix. It is because we can see there is only one column. And now therefore now you have learned about what is row matrix, what is column matrix, and what is null matrix. The next special type of matrix is said to be the Sca Matrix. At the very beginning, it is said as matrix is a rectangular array of numbers. But when you come to this situation, now it is saying it as Sca Matrix. The thing what has happened here is, if generally we are saying that matrix is a rectangular array of numbers, and if you consider about if all the 4 sides of a rectangle is equal, then such a rectangle is named as a square. Now think about this is the general form of rectangle we are having. If all the 4 sides are equal to each other, then such shape is meant to be a square. Here what we say as the rectangle. Therefore, if all 4 sides are similar to each other, then this is named as square. Therefore, we can say that square is a special case of rectangle. Therefore, based on this concept, we are defining the Sca matrix as if a matrix has same number of rows and columns, If the number of rows and columns of a matrix is equal to each other, then such a matrix is said to be a Sca matrix. As an example, it is given this is a 3 by 3 matrix. It is since we are having equal number of rows and columns, you may get it as M by M matrix. It is because n is now equal to M since it is a Sca matrix. Since it is a Sca matrix, what we can identify is number of rows equals to number of columns. Therefore, we can say it as M by M matrix. In this example, you can see that there are 3 columns and 3 rows used here. And this type is said to be a Sca matrix. Then the next type of matrix is the diagonal matrix. Now we'll see what is meant by a diagonal matrix. It says that a diagonal matrix is a matrix having non-zero elements only in the diagonal running from upper left to lower right. Before discussing about this diagonal matrix, first I will explain about the main diagonal of a matrix. Now you have considered about a rectangular array of numbers. Then this is said to be a matrix. Here you had M by N named as A. Then you had numbers as A, B, C, D, E, and likewise you had set of numbers inside the matrix, and you have named this as the general form of matrix. And apart from that, you have considered the new form as B is equal to a Sca matrix. It is quite like A, B, C. You have defined this as Sca matrix. I have taken it as 3 by 3. Now think about this form of matrix. If you are having a Sca matrix in this form, then the line runs from top left to the bottom right. It is starting from top left to the bottom right, then such line is meant to be the main diagonal of the matrix. Therefore, the main diagonal always starts from the top right corner. It always starts from the top right corner and it ends from the top left. It starts from the top left corner and ends from the bottom right corner. Therefore, this is said to be a main diagonal of a matrix. Therefore, generally we are defining the diagonals for Sca matrices. It is because if you are trying to draw a diagonal, then it would be not that much easy on a case like this. Therefore, you have to, if this is 2 by 3, it is quite okay. But if it is 4 by 3 or any other this higher orders, then it will not be that much easy. Therefore, we are not defining any diagonals for rectangular matrices. Only for Sca matrices we attempt to define in the diagonals. Then this is said to be the main diagonal of the matrix. This is said to be the main diagonal of the matrix. This line is said to be the main diagonal of the matrix. And now if you suggest about look about this diagonal elements of the matrix. Now suppose that if you have given a matrix in this form, all the diagonal elements are non-zero values. Here it is 3, 1 and 5. Then now suppose that the remaining elements of this matrix is equal to 0. Now think about this is 0, here 0, 0, 0, 0 and 0. Now you can see that only the diagonal elements are non-zero values, and apart from these diagonal elements, all the other values are zero elements. In a situation like this, now you may see about the main diagonal starting from top left to the bottom right. You can see only the values on the diagonal are non-zeros, but all the other values, the, the values apart from the main diagonals are zero. Then we can say that this matrix as a diagonal matrix, and it says that every diagonal matrix is a Sca matrix. That is why I told you before also, we are defining the diagonals for Sca matrices on every diagonal. Therefore we can say that every diagonal matrix is a Sca matrix. In this example you can see that 2 by 2 matrix has obtained. You can see that only the elements on the main diagonal are non-zero, while the remaining elements are zeros. Here also we can experience the same thing. The elements who are apart from the main diagonal are zero values. Now, based on the behavior of the elements on the diagonal matrix, now we are going to define another two types of matrices, which are said to be the triangular matrix. It is because the values of this matrix is just be as the triangular shape. We are defining such matrix as triangular, but not just saying them as triangular matrices. We are preferred to identify them as whether it is upper triangular matrix or lower triangular matrix. Now think about the first case. In the first case, it says that if the elements below the main diagonal for a given Sca matrix, if all the elements below the main diagonals are zero, then we are saying such matrix as an upper triangular matrix. It is quite like this. Now think about if you are having a matrix in this form. Now you can see if you draw the main diagonal of this matrix, you may get it in this form. Now, if this is the main diagonal we have observed, now we can say that this is the upper part from the main diagonal. See that this is the upper part. This is the upper part of the main diagonal. And this is the lower part of the main diagonal. This is the lower part of the main diagonal. Now you can see that the lower part of the main diagonals are only having zero values. Only the therefore we are not going to worry about the values in the upper part, since we can see that this non-zero values, at least one non-zero value is there in the upper part. We are not going to bother about the remaining values. Therefore, we are focusing on the zero elements in the bottom part or the area below this main diagonal. Now you can see that all the elements below the main diagonals are zero. Therefore, if you match the corners of this, now what will you get is you may able to get a triangular shape on this. Therefore, that is why we can say this is a triangular matrix. But based on the side that you are obtaining the triangle, then we can obtain this as the what we are calling as upper triangular. Therefore, this is how we are obtaining the upper triangular matrices. Then the next part is obtaining the lower triangular identification of lower triangular matrices. It is quite in this form. Now think about in the upper triangular matrices, what we have identified was if all the elements below the main diagonal is zero, then such a matrix is said to be an upper triangular matrix. It is because the triangle has made in the made above the main diagonal. But if you move for the next part, it is the if all the elements or all the entries below the main diagonal, if all the entries below the main diagonals are zero, then we can say if all the elements above the main diagonals are zero, then we can say that that is a lower triangular matrix. It is because now you can see that triangle has made in the bottom part. Therefore, since we can make a triangle in the bottom part of the matrix, then we can say such a arrangement as a lower triangular matrix. Therefore, this is what we are saying as the lower triangular matrix. Then the next part that we have to move is it is the identity matrix. Now we will move for the identity matrix. Identity matrix is also a special case of the diagonal matrix. It is because if you are having a diagonal matrix, then we are saying if all the off diagonal elements or the elements which are apart from the main diagonals are zero, then we say such a matrix as a diagonal matrix. But in here, what we can observe is here we can have this as if you write the matrix in this form, if you have the matrix in this way, then you can see this is the main diagonal, and for the diagonals, the remainings are zero values. The remainings are zero value. Now, if you can find on the main diagonal, if you can see only the values as ones, if you can see the value here is 1, value here is 1, and value we can here is 1. If you can see ones on the main diagonal and for any other off diagonals, if you are having zeros, then this type of matrix is said to be an identity matrix. Then we are naming this identity matrix. Generally, we are naming identity matrix using the letter I, and since this is a Sca matrix, we can say the order of this matrix is n. Therefore, if it is I in the order n, we can say that this is an identity matrix. It means that only the main diagonals are ones and all the remainings are zeros. All the remainings are zeros. Therefore, here we can have it is as n by n matrix. Then we can say this is an identity matrix of order 2. This is an identity matrix of order 2. Here some examples have also included in this note. You can see that here it is given as I1. I1 is said to be a matrix with having one row and one column. This is stated as I1. Therefore, you may have only one value, no any off diagonal elements. Then if you move for the I2, then you may have it as 1, 0, 0 and 1. Only main diagonals are 1s, then here it is 2 by 2, 1 by 1. Yeah, likewise, if you are having I3, if it is I3, what we can obtain is it is quite like 1 0 and 0, then 0 1 and 0 0 0 and 1, and this is a 3 by 3 matrix. Likewise, you can define the n by n identity matrix. But what you have to keep in your mind here is, in the identity matrix, the main diagonal elements are always equal to 1 and all the other elements are equal to zeros. This is again a special case of the diagonal elements. Therefore, every identity matrix is always a Sca matrix. Therefore, we can identify that also. Every identity matrix is always Sca matrix. And the next, this is used for the calculations in many more situations, the concept of equal matrices. If you see about the equality of two matrices, then if following three conditions are satisfying for any given two matrices, then we can say that such matrices are said to be equal matrices. It is quite like this. Now think about if you are having matrix A and matrix B. If these are just numbers, what we can have is only the value. If A is 2 and B is 2, then we can, since the magnitude and signs are similar, then we can say that equality exists. But if you consider any matrix, we cannot have it in that way. It is quite like this. Now think about if A is given as 2, 3, 4, 1, 6, and 5. And if B is given in this way, now think about it is 2, 4, 3, 1, 5, and 6. In this way, you cannot say that if you see about these two matrices, you can see that elements are similar. Then you may say that A equals B. This is completely wrong. It is because it is not just as numbers. Therefore, we have to think about these three conditions. It means that if two matrices are equal each other, the first condition is number of rows should be equal. The number of rows among the matrices should be equal. The next one is number of columns should be equal. And the next important thing is corresponding elements. Corresponding elements should be equal. Therefore, these are the three conditions that we have to look when it is given as the matrices are equal matrices. If you look back to the example which I have taken here, now you can see that A is a matrix having the order as 2 by 3. If I write the order here, I can get it as it is a 2 by 3 matrix, and here also it is again a 2 by 3 matrix. If you consider about the matrix A and matrix B, the number of rows in matrix A is 2, number of rows in matrix B is 2. Number of columns in matrix A is 3, number of columns in matrix B is 3. And if you see about just the elements, here it is, we are having 2, 3, 4, 1, 6, and 5. Here it is 2, 3, 4, 1, 6, and 5. But the order is changed. Now, if we are just trying to make conclusion, just having the equal elements, then you maybe end up with the wrong answer. If we are having equal, here also values are equal. Then this is not stated as the third point. This is the most important thing that we have to pay the attention. It is because we have to think about this term, corresponding elements. It is because the place of the element that it is located should be similar. in between those two matrices. Therefore, what we can do is here we are having matrix A, matrix B. Although we are having equal number of rows for these two matrices and still as equal number of columns. Now we need to check for the corresponding elements whether they are okay or not. Here, if you see the first row, first column, we can see the value 2. Here, first row in the first column, value 2 is there. Then we can say that this part is okay. First row, first column, we can say that this part is okay. First element is okay. But if you see about the second element, in the second element, in this element, second row, first element, we can have value 1. It is in the both matrices, we had it in that form. Now, if you move to the next one, the second column, here we are having 3, here we are having 4. Now we can say that corresponding elements are not equal to each other. Therefore, as soon as we found at least one corresponding element which does not satisfy this condition, then we can say that A and B are not equal. Therefore, if you got the elements in this way, if you suppose that A is the matrix given in this form, suppose that A is the matrix having 2, 3, 4, 1, 5, 6, and matrix B is again 2, 3, 4, 1, 5, 6. Now we can say that this is these two are equal matrices. It is because we can see that here we are having 2 by 3, number of rows and columns are equal, and all the corresponding elements are also same. 5 with 5, 6 with 6. Therefore, we can say that A equals to B, or we can say that A and B are equal matrices. A and B are equal matrices. This is what we can obtain in here. Okay, now we will focus on the example illustrated for these equal matrices. Here it is given in this way. They are saying that if the matrix X is given as the elements A, B, C, and D, while the matrix Y has the elements P, Q, R, and S. And if it is given that these equalities, if they are saying that for the matrix A, we are having the values as A, B, C, and D. For the matrix Y, the values were identified as P, Q, R, and S. Now we can see that this is a 2 by 2 matrix. This is also a 2 by 2 matrix. And if it is given that these two matrices are equal to each other, if the matrices are equal to each other, now the first condition satisfied, row number, the number of rows equal, the number of rows equal to each other, then we can see that the next thing is the number of columns equal to each other. And if you see about the corresponding elements now, we can see that in the equality is given A and P are equal. A equals to P, it is okay. Then B equals to Q, B equals to Q, corresponding elements. C equals to R, corresponding elements. D equals to S. It says that now first condition satisfied, second condition satisfied, the only remaining condition was the third condition. Since the equality exists, therefore we can say that X and Y are equal matrices, and it is denoted in this form X equals Y. This is the way that we can denote the matrix. We can just say this is the matrix X equals Y. And this is all for this session, and thank you all for participating in this session.